Welcome, students. Now let's look at this. I want us to like two nice questions on specific heat capacity. Now let's look at the first one. How much heat is released when a piece of iron metal of mass 5.0 kilograms and 8 specific heat capacity 460 joule per kilogram per Kelvin cools from 80 degrees Celsius to 45 degrees Celsius? How do we solve this question? You write down the information. So we are given the mass of the metal as the 5.0. Specific heat capacity which is small c, four 60 right? We are given, so here is cooling, right? Initial temperature is 80 degrees Celsius. The final temperature is 45 degrees Celsius. So in previous videos, you saw that we found the change in temperature as final temperature minus initial temperature. That is not a fixed formula. We said last time that if you want to find the change in temperature, okay, temperature is a scalar quantity, so it's the bigger value minus the smaller value. So in this case, rather, it's not going to be final minus initial. So it's rather going to be 80 minus 45, right? And get 40 degrees Celsius. So take note of that. Change in temperature is always the bigger value minus the smaller value. Now, how do we find the specific heat capacity of the metal? It's going to be the quantity of heat. Was the quantity of heat given? Oh, that is what we are looking for, right? So let's move on. We are looking for the amount. How much? So amount of heat or quantity of heat, right? That is our Q. Great. So if we know that C is equal to Q over M times what? Theta. This is our theta. Then from this, we can say that if you want Q, then what will be your Q? Q is going to be MC theta, right? So let's move on to the next page and work it out. So we continue from here. So Q, the mass is 5, if I'm right. The specific heat capacity is 460. And this one is 40. All right. We said last time that change in degrees Celsius and change in Kelvin is the same. So looking at this, even though this is in degrees Celsius, this is in Kelvin, there is no need converting this one to Kelvin. There is no need. Okay. So you leave it like that there. You multiply this 4, what do we get? So we are going to get 200. 5 times 40 will give us 200, and 200 times 460. Let's check from our calculator. 200 times 460. We are getting 92,000. So let's come back, get 92,000 Joule. How do we conclude? Go back to the question. So you see that 92,000 Joule. Therefore, 92,000 Joule of heat is released. That's all. You can add the so it's released by the ion. That's all. Very simple.